So now we have an LED here. One resistor is providing current. If I close the switch, the other resistor also provides current and the LED gets brighter. So hopefully you can see that. It's not super dramatic with this LED right there. We'll zoom in, but there you can see there's the 1K resistor, LED, long lead the anode of the resistor, short lead the cathode to ground there. And then we have a 1K resistor to the top of the switch. Bottom of the switch comes to the anode of the LED. Probably looks brighter there. But yeah, here you can see the current on the power supply. Not pressing the button. And now I'm pressing the button. This isn't as accurate as a multimeter, but it's pretty close. So now here's the schematic diagram I drew for this. I drew a finger there to indicate the switch being forced closed. But without the button being pressed, we got about 7 milliamps of current flowing. With the button being pressed, we have about 14 milliamps of current. That's if you have a red LED. They drop about 2 volts out of that 7 volts. With a 1000 ohm resistor, that's going to be 7 volts across it. You got about 7 milliamps of current flowing through there. This switch is open, so no current's going to flow through over there. Now we come over here, and there you can see. Again, we still have 7 milliamps of current flowing over there, but now that we close the switch, we also have 7 milliamps of current flowing right there. So when resistors are in parallel, there's always less equivalent resistance right there. That's still 1000 ohms, that's still 1000 ohms, but you got twice the current. So it's as if you have one 500 ohm resistor, which is an okay value for lighting a red LED.